For question 3, we have our first even root, and so this really just becomes a question about the domain of that function. We cannot allow this to ever have a negative number under the square root. So saying something's not negative is the same as saying it's got to be at least 0 or bigger than or equal to 0. So I would do something like 2x plus 3 has to be at least 0. And I would solve this to say 2x has to be at least negative 3, so x has to be at least negative 3 halves. Any value of x that's less than negative 3 halves, so for example, if x is negative 2, then we have a square root of negative 1. That's not going to be in my interval of continuity. The first thing I can plug in is negative 3 halves, and I can plug in anything larger than that. So there are no points of discontinuity, right? Like there's not a specific point where the continuity no longer exists. There's a whole interval of discontinuity, but there's no point of discontinuity. So I'd say none for that. And then for the interval of continuity, I'd say it's from negative 3 halves off to infinity. And just because I also feel like maybe we don't have as clear of a grasp on the graph of square root functions as we ought to, I'm going to pause briefly and show you this on Desmos just to really drive the point home. But I want to adjust the window. So I'm going to pause my video, and then like magic, we'll be looking at a Desmos graph. So 1 hot second, and here it is. You can check for yourself. Just type in SQRT into Desmos, and then underneath that put the expression 2x minus 3. You'll see a graph that looks something like this, and it's continuous for all these places it's defined. You know, there's no point once I hit the graph where it's not going to be continuous, but of course for these values that are less than 3 halves, there's no function, there's no continuity. This example is probably here to show you that you can have no points of discontinuity whatsoever, but still not have the interval of continuity be from negative infinity to infinity. That's all I got to say about that.